Welcome back. This is Teresa Adams with the Community College of Denver. Today, what we're going to be talking about is evaluating trig inverse functions for right triangles. So we know what the answers are when we're taking the trig function of 0, 30, 45, 60, or 90. We know what the answers are. So when we take the inverse of these, because again we're going to be in right triangles, so we're talking about acute angles, we want to think about what angle produces that as the answer. So as an example, the sine inverse of 1/2. What angle alpha produces 1/2 when I take the sine of alpha? So the sine of alpha equals 1/2. Well, we know for that it can only be 30 degrees or pi over 6 because, again, we are talking about right triangles, so they are acute. And in particular, if we want to put it into a quadrant, we're going to be working only in quadrant 1 at this point. Later, we will talk about, really be concerned about the domain of the inverse functions, about whether or not it's going to be a negative angle or a positive angle later. So, when we're asked to evaluate the expressions below and the answers in degrees and radians, the sine inverse of 1, we want to think what angle produces 1 when I take the sine of it. So the sine of alpha equals 1 when? Well, that happens when we're talking about a 90-degree angle, or pi over 2. Same thing with the tangent inverse of the square root of 3. So we ask ourselves, what angle produces a square root of 3 when we take the tangent of it? So the tangent of alpha equals the square root of 3. Well, when does that happen? That happens when alpha happens to be 60 degrees, or pi over 3. Now, I'd like you guys to do the cosine one. I will give you the answer, but I want you to think about it. And you're right. It's also at 60 degrees, or pi over 3. Now, what happens if you're looking for something that isn't the answers of the 0, the 30, the 45, 60, or 90? Well, then what we have to do is we use our calculator. Do make sure that you are in degrees, because of this example wants us to answer our answers in degrees, so we are looking for angles in degrees. If it asks for it in radians, make sure you're in radians. So I plug in my calculator, the sine inverse is 0.76, and for me to do that, I got to hit my second key, so second and then the sine key, and that gives me my arc sine, or the sine inverse. And when I do this first one to 1 decimal place, I get 49, that's a 4, 49.5 degrees. When I do the cosine inverse of 0.12, I get 83.1 degrees. And then the tangent inverse of 0.063, I get 3.6 degrees. Now let's actually apply this to a right triangle. So on this next example, they want us to solve for the right triangle. They'll give us 2 of 3 sides, or they might give us an angle on a side, and from there we're going to solve everything else. So when it says to solve, they want all of the angles listed, and they want all of the sides listed. As we look at A, it's really a good idea to consider drawing your triangle. So I'm going to draw my triangle. C is always the longest side. It's always the one opposite the right triangle. It's always the hypotenuse, so that's where the 12 goes. It does not matter where you put A or B on the other 2 sides. I'm going to put the 10 here. That means this angle is alpha, and that means this is B. Now we know the sine of alpha is going to be 10 over 12. So in other words, alpha is equal to the sine inverse of 10 over 12. And I get that in my calculator, and I get 56.4 degrees. That means beta, which is this one down here, beta has to be equal to the 90 minus the 54, or 56.4 degrees, which means my beta is going to be 33.6 degrees. Now you think, why didn't I do 180 minus the 56? Well, because it's a right triangle, we know one of the angles, the gamma, happens to be 90 already. That means only 90 is left. So the 90 minus the 56.4 gives us me the 33.6. So now I've got the gamma, which we know is 90 degrees. That's this one right here. So this is gamma. So gamma equals 90. 90 degrees. Beta is the 33.6, and the alpha is the 56.4. The only thing I'm missing now is my side B, and I can use Pythagoras to do that. So 12 squared is equal to 10 squared plus b squared. So in other words, b, when I solve for this, and I'm going to do it to 1 decimal place, actually, you know what? I'm going to leave it as the square root. And so I'm going to do to the square root of 11. Equivalently, I can put this in my calculator, and if I put it in my calculator to 1 decimal place, it will be 6.6. Now on the next example, they give us beta, the angle, and they give us a side. So I'm going to give myself a little more room. Kind of ran out of space there. So again, I'm going to draw my triangle. Here is gamma, and we know what gamma is right out of the way. Gamma is equal to 90 degrees. I'll write it the same way. So here's my beta. Here's my alpha. Across from alpha is my angle, or is my side A, which is 3. I'm missing C, and I'm missing B. But I can find my alpha right away. Alpha is going to be equal to the 90 minus the 47, which for us will be 43 degrees. And these are 4s, even though they kind of look like 9s. These are 4s. So I've got my 3 angles. So now what I have to do is figure out my sides. I've got alpha and I've got the A. So I know the sine of alpha is going to be the opposite, which is 3, over my hypotenuse, which is C. But I know what sine alpha is. The sine of 43 degrees equals 3 divided by C. So when I solve for C, C is going to be approximately equal to 4.4. So I've got A, I've got C, and I'm missing B. And again, I'm going to go back to Pythagoras. So I know that the 4.4 squared is equal to the 3 squared plus B squared, which means that B is approximately equal to 1 decimal place, 3.2. Thank you for watching.